Hello, everyone. Welcome to another episode of our series Lunch and Learn, where we bring interesting topics in the world of tech and web development right to you. Uh, Remember that if you're watching us live, you can leave all of your questions on the YouTube chat and we will get to them at the end of the stream. Today, we have a very interesting topic. Carl Heidman is with us and he's going to talk to us about fractal refactoring. This is a very interesting topic to me. It sounds like something that maybe we should all apply when we want to refactor something in our code, make our code more resilient, way better. Carl works with our client Civic Plus here at JobCity. He is a full stack developer. Hey, Carl, how are you doing?
Hey, Sebastian. Fine, and you? Well, hello, everybody. I am Carl Heitman, and I am going to talk to you about fractal refactorization. This is a fractal approach that you can engage to refactor large files. So let's go to it. Well, first of all, let's talk about the standard approach. The standard approach we are all used to work with. It is based on modern science, right? And it relies fully on categorization. What is this? It is you take different elements that have some similarities, and then you categorize them, and you try to make a law that will command these elements, right? It has to do also with order. It remembers me also like Newton. Mr. Newton, when he created the gravity theory, right? What is gravity all about? It is to take objects in real life that has mass, and he made a series of observations, and then he finally came with a law, right? And the principles of Newton, and we have a lot of mathematics there, and it is like categorizing, right? Well, this is a similarity to what we are used to do, because on our code base, when your code base starts growing up, what you intend to do in most of the times, it is to see which elements are similar and then extract them and bring it into a library. And then in your other components, in your other pages, then you call these elements and you instantiate it on whenever you like to use it, right? So that's the rough idea. Now let's talk a little bit about math. What is math? And there are someone who says it is the language of the universe, right? It is how it is all written. But I think it is way simpler than that. Math are symbols, right? Are symbols you use to abstract from the real world, and the symbols used to represent something: addition, subtraction. For example, the number 3, right? The number 3, if I've got 3 times mutons, it represents that you have in real life 3 mutons, right? 3 exact same mutons. Here I draw it a little different, but you've got the idea. And this is extremely important to understand things like vectors, derivatives. Derivatives, it is the change, right? You are measuring the change. Vectors, I remember I had a lot of trouble when I was in the university, because I didn't understand that vectors were symbols. If you have in 3D space, you have the first number, the second, and the third. Each one represents some amount in the x-axis, in the y-axis, and in the z-axis, right? So they are symbols, and you must interpret them like that. Now let's talk a little bit about the fractals. Here I have a a broccoli, right? Here we can observe a broccoli, and this is a nice vegetable. I really like broccoli, and it has a peculiar characteristic. It is that you can see the broccoli as a whole, right? But if you take a knife and you cut a piece of the broccoli, you can see the little broccoli. It has the same structure of the big broccoli. Yeah, and you can continue on. You can continue cutting this broccoli down to pieces, and you have the same structure, right? This fantastic. And fractals are everywhere, or not everywhere, but in many places you can see fractals. You only have to see, observe reality. Now, some formal definitions about the fractals. It is by Mr. Benoit Mandelbrot. He was a guy who was in charge of doing some measurements on England. Right here we all know this Iceland here. And what he figured out was something odd. He started measuring the perimeter of the Iceland with this unit of measure, right? 200 kilometers. And he found out that the length was 2,400 kilometers. And there is this thing that is odd. It is that he started taking smaller measurement units, and he found out that the length diverges, it does not converge. It is counterintuitive, this thing. And he later on made the definition of fractals that it is a figure that has a finite area, but has an infinite perimeter, right? So, and here is why he coined the term fractals, because it looks like you are fracturing the lines of the coast. You start with a big line, and then you fracture it. And if you can see the mess I did here with the broccoli, I took the big broccoli and I started fracturing the broccoli in smaller pieces. And so this is something very I like very much about fractals. Now here you can see the famous the Mandelbrot fractal, right? It is a figure that you can go inside, and you will always see different figures. So it is like deep diving inside the coast of England, right? Or any other country. You start, it is kind of entering into a rabbit hole, and you find more things, and more things. And that is what we are going to see in this method, right? So let's go to see some main characteristics I defined here. One of them, it is the recursivity, right? This is not very cherished by academic people. I remember I saw a talk of a CEO, and he said, oh, if you see recursivity, a CEO of an educational company, and he said, if you are going to use recursion, forget about it. No, don't put your hands in recursive things because it is dangerous. And so that's why people don't. I don't want to constrain it to only academic people, but there is a lot of people that don't like recursivity. There are some interesting things about recursivity. For example, any for loop, you can turn it into a recursive function. That's why there are some languages that don't have for loops, or maybe it is hidden, like Haskell, only functional programming. So it is something, well, Haskell was created by academic people, but that's the reason why there are exceptions, right? Fractals are recursive because one of the simple fractals you can make, I have it on my webpage, an example in Vue.js. It is a Fibonacci, right? It is a Fibonacci. It is a Fibonacci string. Kind of follows the sequence of Fibonacci numbers 1, 1, 2, 3, 5, 8, etc. But it is with a string that has 1 and zeros. And you can say to the cursor to draw these 1 and zeros, and you end up with some cool fractals. With one fractal, and you can tweak a little bit the algorithm, and the fractal will change a little bit. So recursivity is important for fractals. And also, if you see this is recursive because it is getting into again and again and again and again. And another interesting thing it is that you can use for fractals, it is functional programming. It is also, it is on my experience in the university. I didn't have much classes about functional programming because the OOP seems to be the favorite for everyone. I think maybe it is because its origin was in a language that was used to simulate things. So if you have the power to simulate things, it is quite tempting to think that everything can be simulated, right? And we have even some theories that says that we are living in a simulation, but I think that is absurd. But it is the feeling you've got when you can create something and it is very similar to reality. Functional programming, I believe it's more modest. Because it has only functions. There are a lot of memes. There are lots of memes about functional programming, and it is like function. But the mindset you have when you are working with functions, it is that you start thinking in terms of input output, and you forget about sending messages, and you have to grasp on some concepts like immutability, pure functions, and things like that. Okay, so it is interesting it is a good tool to use if you want to work with fractals. But now let's go see some examples. You can find fractals not in the real world, but in your computer. For example, the trees, like the DOM in the HTML. What is the DOM, the HTML language? You have here your root node, that is the HTML tag, right? And then you start nesting more HTML tags inside. And why this can be a fractal? Because someone could say this is a graph. But I think that graph and fractals share many characteristics. For instance, if you put this bad guy here and this other bad guy, you can see that they are equals in terms of structures. So we go again with the broccoli, right? It is the root, the branches, and here is the little broccoli that was cut from the big broccoli, the small broccoli. And you have also a root node with other branches. And if you go in the little, you can see the same structure. You can see where we are going, right? You are digging into the object, and you find always the same things with little variances, differences, but it's a fractal. Also, you can see the files and folders. Here we have a pretty lame drawing of a folder, right? That has contents inside, other folders inside, and files. And you can double click a folder and you will start getting into the same thing, start diving in getting inside the fractal. This is your file system. It is wrote like that. What else do we got here? We've got, oh, this is pretty cool. The web browser, I mean the web pages, right? Here we have a standard web page that has contents, and you can see this is the root, and this is a portion, right, in blue, and inside you've got more things. And this is the structure of a web page. It is a box with things inside, as simple as that. Okay, you've got a box and things like that, and things inside, and they are boxes, the same structures. So now I would like to show you an example here. Yeah, let's go to see Conundrum, this web page, word reference, one of my favorite pages. You can see this is a box with things inside, and you can see here with the inspector that I've got a box with things inside. Here you have a box with things inside, with boxes inside. It has some leaf, and it has some folders in the previous analogy, right? And you can go, you can dig deeper. And here you can see the tree, the HTML tag, the body tag, and it has more trees, subtrees inside. So this is the inspiration for the fractal refactorization. I would like to, if we continue with the presentation, the slideshow, here comes the demo time, because I could put on some screenshots here, but I believe that it would be better to see an example on how to do the fractal refactorization. So let's go to it. Here I have a Figma design. It is the Poke API, right? And I want to create this application. I already created it. I am using the Poke API to get the data. And here you can see first stage, they are buttons with the Pokemon name. And you click a button, you will see a card with the figure of the Pokemon, its abilities, and its types. And if you click an ability, you will get the name of the ability and a description. If you click a type, you will get this. Okay? So, you can see that this can be a pretty large application. So first, we are going to see the modern approach in action that will consist on represent each of the components the application have. So we have a component that is a card, another that is ability, and another that is type, another that is damage relation that will show you the type, in this case grass, and then the damage relation, double damage from flying, blah, 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 blah. So let's go take a look at it. And another important thing is that the subcomponents, they have a state of, like the ability here, state of without description, and state on, the ability name with description. The same thing for types, right? Off, on, off, on. So this is what it looks like. Here it is the modern approach. Here I have my components folder, and here I have the card. I don't want to take a look at the code because I will assume you can all do the code because this is basic stuff. I want to focus the fractal refactorization on how to use your file system to use it as a leverage to organize better your code. So here I have the card component, and here I have the type and ability component, and damage relations component and move component. It is all flat here. But if you take a look here, can you see at one glance which component is nested under the other component? It is quite a mess. And what if the card starts growing much more? you will end up with many components here on this folder. And then you can take another approach, that is to create a folder named pages and start putting there all the components of this page. So here we will take a quick glance. Here is the component, the template. I want to focus on the template, the card, the type component, ability component. And here the most simple is ability. Here is the template, some div, and the type. Here you can see this is the state on, and here we have the damage relations and moves. And the else, this is the state off. So let's see how this becomes if we use the fractal refactorization approach. So I'm going to check out to the master branch, and here we have. We turn our file component into a folder named card, and let's see what's inside the card folder. This is an index. This is the file that will orchestrate everything else. So if we take a look here at the sibling of index, we have the no data component, a very simple component, 51 lines of code. And this is going to do the fetch to the port API and then send an emit to this index. So the index will load this other component. This could have been a file, but it is a folder, right? But before we go to the folder, let's see the index. Here it is, vif, velse, data, no data. And here this approach has the benefit that you, in each folder you create, you have a brand new namespace. So you don't have to get creative with names, because you can reuse the names in the folders you are nesting, right? So let's see what we've got here on data folder. The same structure, can you see? Index.view. And here this folder doesn't have any other single file, like the no data. Let's take a look at the index. This is very similar to what we had earlier, the type and ability, two components that are nested here. And these components, we say the ability was simple. So this is, we've got the end of the line, index, the main file, and he will command the ability data and state of. Ability data and state of. We are nesting, we are getting inside the fractal. And the other one, the type, take a look here. An index, state of, and more data, because the type, when it is on, it has damage relations and the list of moves that I forgot to show you on the Figma file. Just wanted to do it this way to show a more complex example. So the data, the index, has the damage relations and the move. Now I wanted to show you how to do it live, but I think we will rely with Git because I made a mistake. The question is this, the damage relation, let's take a look at it. It is a big file. It has 71 lines. It has more lines than the ability, 22, or than the move, 25. So this file is pretty big, right? It has a lot of data. I didn't show you the application running. Bulbasaur, overgrow, grass, and here double damage from, this is type, and I can click it, and it is recursive. So it is calling the again the type and again the type and again and again. But take a look at the damage relations component. It is gigantic. Double damage from, double damage to, half damage from, half damage to. And here we can continue refactoring this file. And how can we do it? Well, it is very simple. We can see it here. I am going to go to the next commit. That is this bad guy here. Check out branch. Take a look at this. I turned the file into a folder with the same name. Inside I put the index.view file, and take a look at this. Here I extracted the double damage from that looked like this, and I put it in a sibling component, and here I am calling it. And we take a look at this component, and it is a small component, right? So you can continue. The algorithm, the approach is this. You can start with a simple file, and as it grows up in complexity, you can start chopping it. Okay, you can start cutting it into smaller chunks. And here I have my cookie jar. And since the broccoli, it doesn't fit in the cookie jar, you can put the smaller broccolis inside. And the cookie jar, the folder, will take these smaller broccolis, and the cookie jar will recreate the component. That's the idea. So instead of taking the smaller broccolis, that is what we did here on the modern approach. Instead of taking your big broccoli and cut it into smaller broccolis and scatter all around the components folder, you can take many cookie jars, many folders, and you cut the smaller chunks of the broccolis, and you put these little broccolis that are related somehow in a cookie jar named double damage, for example. And this is a way to organize your code. I think this is pretty much of it, the fractal the fractal refactorization approach. So let's return with the presentation. Slideshow. And the conclusions. Okay, this ain't a silver bullet. This is the first thing you must get. This is not a solution that will work for every problem you will have. This is a solution that it is intended to be used on cases where you can't apply the modern approach, right? The approach we are all used to do, to categorize components. If you have this idea came to me about the fractal refactorization approach when I got into a project, when I had a button on a previous company that was about 700 lines long. And this was a super important component because it was a single button but had 3 states. And these 3 states were complicated. And in all the application, that was a very, very big application, you didn't use it anywhere else. So the people that was working with this component, they had a lot of trouble to test it and to change a little thing. And they didn't have an idea on how to categorize that component, because it is right. You can categorize something that is unique. So the fractal refactorization approach is meant to be used with things that are unique. You can categorize them. And for everything else, if you are building a library like Bootstrap, that you have a lot of different components in categories, right? The accordion, cards, alerts. Okay, you can categorize things there. But in many cases, in real world applications, you will find things that are pretty unique. And with things that are pretty unique, you can turn your files into folders. And so use fractal refactorization approach in cases where you can't categorize elements anymore, and categorize elements that you can indeed categorize. This is what I was meant. You can indeed categorize buttons with different colors. So you create, here you can use the OOP, it is fine for creating interfaces and things like that. And as the last point, it is always important to refactor the code. I know this goes a little bit against rules, because I remember yesterday that I seen the Zen of Python some years ago, and in it now these things goes against the fifth rule of the Python Zen, the rule that says flat is better than nested. You can search it. It is the PEP 20, Zen of Python, rule number 5. And this is not true. But that's the reason why I don't code in Python. I use Ruby, JavaScript, and the language that I am trying to learn now, it is Rust. You must see, depending on the context, what to do. Flat is better than nested in the Bootstrap library, of course. But if you have something unique, then I think you should be nesting things. And that's all. Any questions?
Hey there, Carl. Thank you very much for the presentation. It is a very interesting approach, the one that you just presented. I can see how Fractals gave you the idea to go towards it, nesting and nesting and nesting and finding more and more, which creates a very nice readability paradigm, right? That's what you are trying to extract from it, right? Make it more readable on the long term. Even though, and I believe that's what the Python Zen means by flat better than nested. It may be a little bit daunting when you see a whole bunch of folders falling off of them at the beginning, right?
Yeah, sure.
So when would it be right to say maybe we should stop nesting and think about creating a different structure, right? I imagine at some point you may have to say we should stop at this level, right?
Oh, yeah, that's a good question. That's a good question. With your question, I remember about some design patterns. There is a trend right now about microservices, or I don't know. I am, but I'm pretty sure that there are some design patterns that you can split your application in smaller projects and then join them together, right? So if you are entering into a rabbit hole where you start nesting, maybe you should start thinking about creating another project that will get nested. You can cut this process at halfways, and I think it is a matter of experience. And you have to practice, and you will start sniffing when it is time to create a new project, because there is a big difference between the fractals and why I say that people in the academy don't like these kind of things. I don't mean only fractals, but I mean turbulences, chaotic things. They are difficult to predict, right? It is not like a parabolic shot on Newton that you apply with a 30-degree angle and you apply 20 newtons of force, and you can predict where the ball will hit the floor again. There are a lot of things, even in the agile, when you are doing some agile with scrums and things like that, you are iterating. You are trying again and again and again, and you are fixing, you are tweaking things. You don't have a formula. So I think it is important, the experience part. Say when we should stop and create another thing and nest it. And even different projects, each one they have their file structure of folders and files nested. So it is the same. If you have a big project with a lot of nested folders, it is the same that joining together two projects that have a lot of nested folders. I don't know if I'm rambling too much or...
No, don't worry. Actually, what you just said reminds me of when you have any project on JavaScript using NPM and you install a whole bunch of packages into the node modules, and enter any of those packages and you will see each node module package has its own packages that it has to install, and those also, and it's the same thing as you already said. So it's a fantastically good way of looking at this same approach as NPM uses for your own project, right? Package each single thing, make it readable for long-term future, even though in the short term it might be a little bit weird to look at. It goes against many of the things that we've been told about how to develop before, right?
Yeah, right. Well,
right. Thank you very much, Carl, for this presentation. I know that a lot of people were very interested. We will share the slides later on our Slack channels. Please, Carl, make sure to send it to us so we can send those to the people who are interested in it. And remember that if you missed any of our past Lunch and Learn sessions, they are all on our YouTube channel. Give them a watch, give this video a like, subscribe to the channel. We will see you in the next one. Hope to see you, Carl, in another instance of our Lunch and Learn sessions.
Well, thank you very much for the invitation. It was very fun.
Thank you all.
Bye-bye.